Hello and welcome to the Fully Charged Show podcast. Now, I want to apologise right from the absolute tippity top. Apologise for not having a podcast released last week. We just couldn't do it. It just became too complex. We've done pretty well because we started these podcasts last year, about just coming up to a year ago, and we haven't missed one yet. And last week was a bit of a problem. I was in America. It was just too complicated. But there's going to be a news episode coming up soon on Fully Charged on YouTube, which explains some of the complexities and difficulties we've been through this winter. It has been a bit challenging, let's be honest, but it is all getting much better now. And I'm really excited about this podcast because this is the first talk that we're able to release from Fully Charged Live USA. This was recorded at the Circuit of the Americas just outside Austin in Texas. And it was, as you'll discover, it was an amazing event that I heard about and saw lots of pictures on Instagram and Twitter. And loads of people went and it was really successful and everybody loved it and everybody had a good time and it was amazing. And the weather was fabulous and it was absolutely extraordinary and I wasn't there. But that will be explained in future episodes and things like that. It's all marvellous now. So Chelsea Sexton, who is amazing, leads this panel discussion, which is all about, can batteries be ethical, recyclable and sustainable? This is a really, really important topic. And we're also going to be, I'm very excited about this, Helen Chesky is going to Germany to see an amazing battery recycling plant very soon, which will be on Fully Charged Show on YouTube. And what we're looking at is amazing amount of recyclability and materials cleansing. It's amazing what they can do. They get all the lithium out of it. They get all the cobalt out of the batteries. It's about 95% of the materials in the batteries can be reused to make new batteries. That is difficult to do with fossil fuels, let's be honest. But let's leave that for now because we're going to hear a really interesting discussion. The varied panel that Chelsea chaired at Fully Charged Live included Vivas Kumar from Benchmark Minerals. So I've had some stuff to do with Benchmark Minerals in the UK. They really know their minerals. Hans-Erik Melin from Circular Energy Storage Research and Consulting. Marc Kohler from Lithium Works. Zarko Medeldzija. This is a difficult name to say for me. Zarko Medeldzija. That's what I'm going for. And I do apologise, Zarko, if I've really made a mess of that. From American Manganese. And Nicolas Tremblay from Nouveau Monde Graphite. Didn't say graphite very well. I'm going to do that one again as well. Nicolas Tremblay from Nouveau Monde Graphite. So, here it is. Coming to you live from Fully Charged in Texas. Y'all enjoy.
Obviously, there's a bit of chatting about recyclability before. It's an ongoing topic in all things EVs. They are recycled, they aren't recycled, they'll be used again first before they're recycled. We can recapture elements that are worth financial money or not. What is the reality about the recycling process toward the end of useful life in electric cars today?
So I've had a couple of you visit us at booth 304 at American Manganese. So we've developed a patented process that doesn't involve smelting the battery down into a black slag and not recovering high quality material. We use a leaching process that recovers lithium, nickel, manganese, cobalt, and aluminum. And our focus really is on I've had a lot of you tell me, the EV is going to last another 10, 15 years, and then it's going to go into reuse, and those are all fair arguments. But if you think at the battery manufacturing level, when they're making this material, a lot of that goes into manufacturing waste, which is what we're calling cathode scrap. And it's still very valuable. And it's what we're sourcing and recovering the material with. This is kind of like the low-hanging fruit. And you can come by our booth and as well and see some of this material. But if you want to imagine it as like if you're doing some woodwork and you have shavings and trimmings and whatnot, but the material is actually very valuable, and this is what we're recovering and at high purity, and this is what we want to be used directly back into the manufacturing process to make new batteries and promote a circular economy.
So my name is Melin. I work as a consultant in the end-of-life space of lithium-ion batteries. So I basically follow all the batteries around the world. When they are placed on the market, when they reach end of life, what will happen with them? Will they be recycled or reused? And the truth is that we do recycle batteries. We have been recycled lithium-ion batteries for more than 10, even 20 years. Most of the lithium-ion batteries are obviously not in your cars. They are still in your phones, in your laptops, and others, and they've been recycled for a long time. And a fun anecdote is, in fact, I don't know whether you know that, but the first patent for battery recycling, for lithium-ion batteries recycling, was already filed in 1993 here in Austin by Valence. So, I mean, it's a long story, but you have basically all of you recycled materials in your phones or in your laptops, and many of you in your electric cars as well. In particularly in China, where 2/3 of the battery materials are made today, recycled materials is huge, and it's a very important component in it, and it has been for a long time. I think the biggest problem in our perception of battery recycling is really that, first of all, it's one pillar of that is used in the dark side of the EV, that it should be so hard to recycle the batteries, which is not. So it's really our understanding is so bad about this just because we are not recycled so much batteries right here in the US, neither in Europe, but that is because most of the batteries, all the materials are exported and they are recycled elsewhere. So it's not really anything to be worried about in that sense. We would definitely recycle more than 50% of the lithium-ion batteries that are placed on the market today.
My name is Nicolas Tremblay. I'm with Nouveau Monde Graphite. I'm not going to tell you much about recycling. I think that the previous panelists did a good job. What I'm eager to tell you, though, is what we're doing in terms of sustainability. But for now, I will pass the word to my other colleagues here.
Thank you. Hi, my name is Marc Kohler with Lithium Works. From a battery manufacturer's point of view, we're obviously interested in the full recycling process. But from a design point of view, we can do some things that really help us with the reuse point of view. That after your initial use of why you bought the battery in the first place, to reuse the battery for its second life. And from a battery's point of view, we can do some things like modularity, such that a 100 kilowatt hour, 600 volt electric bus, when it's done, can be removed and reconfigured if the batteries are modular, such that it's a 48 volt, 80 kilowatt hour stationary energy storage solution. So modularity really helps out with the second life aspect of things.
Hey everybody, my name is Vivas Kumar. I'm from Benchmark Mineral Intelligence, which is a company based in London which looks at the battery electric vehicle supply chain. Previously, I worked at Tesla for about 3 years managing their raw material supply chain. So if you look at the question of recyclability, there's one sort of force that goes in the direction of recycling and one that goes against it. So the force that goes towards recycling is, whereas previously companies were looking at recycling as a way to ensure compliance with laws, now they're looking at it as a way to get valuable materials back, especially in the face of huge raw material shortages that are coming up in this industry. A lot of the panels have already touched upon this, and we'll talk about it more as well over here. Now, one force that's going against recycling is, for it to be economical and to produce value, you need a huge amount of batteries coming back. So you need very sophisticated collection processes, and you need a large feedstock of batteries coming back. Now, the issue over there is EV makers, they're facing the pressure of making sure that their batteries can last longer and longer and longer because of customer demand. So if you have, let's just say, 1,000 units of batteries produced today, that doesn't mean that 1,000 units are going to come back to you 5 years from now. They're trying to push that out to 6, 7, 8, 9 years. And without that large feedstock coming back, that may make the economics challenging.
I'd like to go back to that one actually, as well as what I was mentioning on the manufacturing waste, because with Benchmark Minerals does a great job of doing a mega factory tracker and how much battery production there is out there. And from our conservative estimates, I would say is about 10% of manufacturing capacity goes into waste. And this is low-hanging fruit material with the cathode materials on there, easily accessible, leachable, and this can be directly circulated back into the manufacturing process. So I think there is a direct one as well, but there is the argument as well that, you know, EV batteries may be 10 years away, but looking at the scrap market and the manufacturing waste, that's a huge opportunity there.
So, Nicolas, going back to the sustainability issue, what is not being thought of there, not being kept in mind? And we're all hearing about, you know, German diesel cars are somehow cleaner than EVs and things like that. What's the reality in that scenario? But also, let's accept there is no free lunch, and we do need to get better with some of the materials we're using, but also not exploiting people to get the gadgets we want and the batteries we need and all of that.
Okay, so I'll speak about the graphite market. But if you guys want to Google 3 words, write this down. Just Google Washington Post graphite, and you'll end up on an investigative report that journalists from the Washington Post did after visiting the mining operation in China, the graphite mining operation, and also the purification that they do there. They use HF acid. Hydrofluoric acid, which is really bad for the environment, and they release the stuff in the environment without really properly processing the acid. So there are huge issues there in terms of sustainability. And what we're doing, the company I'm with, in order to address this, we're coming up with a mine in Canada, in a province where we have hydroelectricity. So it's 100% renewable electricity, and this mine will run all electric. And also the purification process that we're coming up with is a thermal process. So no acid whatsoever. We have an oven that we've been working on for the last 2 years. So it's a proprietary process. Our aim is to achieve the lowest environmental footprint of the graphite industry in order to produce the graphite anode material that is, deeply needed in North America and Europe. There is currently zero supply of graphite anode material in North America and Europe. It's all from Asia, mostly China.
Going back to the economics of it, we've long talked about sort of we're going to be able to take batteries out of our cars and then put them in our garages and use them a few times and that sort of thing. And on the flip side, I get people who argue with me, battery experts, that say, no, battery costs are falling so much, it's not going to be worth it to use used EV batteries. They're going to be worthless. We'll just recycle them and continue to deploy new ones that get cheaper and cheaper for the next 5 years or so until something levels out. What's the reality there?
I think it's really, when we talk about this question, it's so important really that we think about from whose perspective are we looking at it. If I'm an energy storage company and I provide services to the grid, it's not that I'm really looking for used batteries. That should be my first choice. Obviously, I would like to have batteries very well specified for the very purpose for which my systems are working. So you hear often from the energy storage business, now, no, we don't want used car batteries we don't know anything about. But if we look from the other perspective, look from the battery owner. It's not today you are the battery owners. If you crash your vehicle, it might be the insurance company that's a battery owner, and they will sell it to a car dismantler. Now they are the battery owner. Their only job is to make as much money as possible. And if you take a Tesla battery, for instance, you can get about $15,000 for a Tesla battery unseen, basically. The material value in that battery, recoverable material, is about 1,500. That's not bad, but it's very far from 15,000. And that's before I even took a screwdriver or started to dismantle this battery. So there's a lot of cost before I can actually recover that material. And this has been the case already in the portable industry. Most of your laptop batteries, they ended up in small power banks. I got it from Audi, thanks to I was driving their car today. There you have reused batteries. So lithium-ion batteries have been reused for a very long time. And if you look at most of the batteries that reach end of life today, they go in different kind of reuse applications, such as what we already talked about here today, about conversion from electric cars or ICE cars to electric cars. But that's just a very small part. A lot of OEMs like Nissan, Renault, Daimler, BMW have their own programs where they are using these batteries, and it's profitable businesses. So if you look at it from that perspective, there are so many companies that see opportunities in reusing the batteries. And for recyclers, I will end there, but I will just say that for recyclers in the US, this is great, because this means that the battery they stay here. They will die here and not somewhere else. So the recyclers in the US can get hold of the batteries, consolidate it in one place or a few places, which increase the economics for the recycling. So it's great.
If I can jump on a couple of points that you made, Hans, very good points. So number one, there's a lot of variability by geography when it comes to policy on what happens to a battery at end of life. So in some places, you as the automaker must have a strategy around what to do with this retired battery in order to ensure that the materials don't end up in a landfill. The policy around battery recycling is not very refined. Lithium-ion batteries and lead-acid batteries are basically still lumped into the same category. And a lot of the fears of sort of toxic runoff from lead-acid are being applied unfairly to lithium-ion. So a major trend that's going to impact what happens to end-of-life batteries is how this policy evolves over time. The second point is, just because a battery is at end of life doesn't mean the battery is dead. So electric vehicle manufacturers will say that when a battery is at about 80% of its useful life, it's at its end of life. 80% is still quite a bit of value that can be used in other less energy and power intensive applications. And there's a lot more value in using that full battery cell or that battery pack for applications like energy storage than stripping it down, throwing out the plastics, throwing out some of the metal. I mean, if you used your shirt and you used it only twice and threw it out, even though you could wear it 100 more times, that would just be ridiculous.
From an economics perspective, which one of those scenarios is making more sense as battery costs drop?
The variable that matters the most is what is the dollar per kilowatt hour cost of producing these batteries? Right. Yes, the dollar per kilowatt hour cost has gone down probably 10x in the last 10 years.
But what's the per kilowatt hour cost of recycling them?
If you take a Tesla battery, for instance, sorry, but it's basically $26 a kilowatt hour in recoverable value in that battery. But that is before you've been running it through American Manganese process, or even started to dismantle it, or even transport it from the first place. So it's not really $26 a kilowatt hour. It's much, much less, obviously. It's still profitable. And process like yours really enable definitely a profitable recovery and recycling of it. But you have value that is so much higher before that. And that is a problem. That is why you see many batteries not being recycled here, because there is somebody that wants this material or wants these batteries more than companies here in the US. Or it can still be here, but it can't be the recyclers, because Tesla don't own the batteries. So they have to purchase, if they want to recycle the batteries, they have to pay $15,000 a pack, which you can't do if you would like to recover the materials. So it's really that it's the highest bidder will always get the battery. That's the simple as that.
Questions?
Hello. the issue of cobalt in batteries has come up a lot, and I'm wondering, based on what you're seeing from Tesla, are they creating a new battery that may not have cobalt in it, or is that coming in the future? Or I know they wanted to reduce that, and there was been some I guess lawsuits about cobalt being in batteries. What's the future look like with respect to that element in batteries?
Well, there's a few things. Yes, everybody, I believe, in the mixed oxide world is trying to reduce their consumption of cobalt and use in the batteries. But there are also other chemistries that don't use cobalt right now. Lithium iron phosphate is one example. So I think everybody is going after that cobalt-free goal.
Hi, I have a question about kind of like what Chelsea was talking about, taking a battery out of your EV and then using it as storage later on. Just to speak for myself, like an old Nissan Leaf, right? You've been driving for maybe 100,000 miles or whatever, and then you'd like to make that the equivalent of a Powerwall. Like, is there any company that's offering that kind of service? Is there any future there other than in like industrial style, like you were talking about with like a bus battery, right? Much larger scale. Is there any future there for consumers to to turn their EV into storage for themselves later?
There are several really, and I think in fact some of these ICE car converters that are here, they are also doing that in some extent. One company not very far from here in Oklahoma City, Spears New Technologies, they are primarily doing remanufacturing, and that is really the first choice. When you get the battery, and especially when it's still within the ownership of the OEM, they want to remanufacture the battery so they can repair it or they can change a few modules. But those modules that are not fit for remanufacture, they will be repurposed, which is what you mean, that builds energy storage system, for instance. And there are others that are using the entire packs as well. Of some reason, this really started here in the US. Here we saw a lot of these small entrepreneurial companies, but today I see much more in Europe. But also in Asia, you see it a lot. But I think there are a lot of companies really. If you are interested in this, there are really small, everything from more advanced do-it-yourselfers to really professional companies that are doing it. I can just add, actually, while we're waiting, Eaton, also an American company, is maybe the company that has actually done it in larger scale, really, to use exactly Nissan Leaf modules.
Hello. So I have to look at my phone. So I'm just kind of curious, as far as like battery technology goes and the advancement in battery technology to new chemical elements like lithium sulfur, lithium fluoride batteries, how prepared is the recycling process is going to go and be for new battery technology as it emerges in the next coming decades? Or is it going to be something where we have this battery technology for 5 years in cars, and then we have 4 or 5 years until they're going to start seeing recycling necessary, and that's when that infrastructure is being built? Or is it already in preparation for new technologies emerging, even like solid state batteries?
I mean, I think you hear a lot of news on the newest and latest battery technologies, and the realization of how long it takes for that to actually commercialize, is still maybe a decade away. And the amount of capex that's going into the current battery technology and how much is being produced on a yearly basis, that's an immediate concern right now, especially for recycling and recovering these materials. And when you look at some of the battery technologies like solid state, it's not changing, not all of them are changing the cathode, where you're still using a lot of the nickel, manganese, and cobalt. You're kind of changing a liquid electrolyte to a solid electrolyte, or changing the graphite anode to a lithium metal. So, there's still the metals there that can be recycled. And, like a process like ours, where we're focusing on like the cathode metals, which do make up about over 50% of the cost of the battery materials, I think they'll be there for the next decade to come in battery technology.
I just like to comment also that you see in research, you see a lot, in fact. I'm myself on the board of the Battery Fund in Sweden, where we fund research for for battery recycling, and we see a lot of projects in, for instance, lithium sulfur and even solid-state batteries. So on that stage, there is a lot of research, but not more than that. And it shouldn't, of course, because the batteries are not even out there. But I want to go back once more that actually the Balance or Lithium Works, 3 years after their own funding here in Austin, actually worked on the recycling of the batteries they were producing. And I think that's kind of the pace we will see for others as well. I mean, we still need more technologies for the absolute later stages of the lithium-ion batteries, and not lithium iron phosphate. But I think at least it's nothing to worry about. That will be taken care of.
Can anybody speak to the available global supply for the minerals that are needed for all these batteries? Like where does the point come where we go, we ran out of those too?
Yeah, I'll take that one. Well, you know, as graphite, it's as I said, it's coming all from Asia at the moment. I mean, there's zero supply in North America, zero supply in Europe. From a security of supply point of view, it's totally unacceptable. I mean, look at all of these battery gigafactories that are popping up. We're at 6, plant in the U.S. The biggest one, obviously, is Tesla in Nevada. They're currently producing at 35 gigawatt hour. And I heard Elon Musk saying that he wants to crank that up to a terawatt hour of production, but he didn't mention the time scale. But anyways, I mean, I think it's feasible for them to be at 100 gigawatt hour within a couple of years. You've got a number of battery mega factories in Europe. I mean, they need a supply. They need a sustainable supply of graphite and lithium, and I don't see that happening. I mean, we're coming up with a mine, but it's going to be 100,000 tons of flake graphite per year. But the industry needs a lot more than that, and Vivas can tell you about that.
Yeah, there's a long and complicated supply chain to actually get from material coming out of a mine to what goes into a car. And there's plenty of chemical processing steps in the middle. So the two questions to ask is, at what point in the supply chain is there not enough capacity? Not just is there enough raw material, because there's many different elements, especially for lithium hydroxide, nickel sulfate, where the chemical processing step is where there's not enough capacity. The second is, there's enough lithium on Earth for millions and millions of cars. But can it be economically extracted given today's technology? The answer is no. We need chemical process innovation and mining process innovation. Mining technology has not really evolved that much in the last 70 or 80 years because there hasn't been a need to do so. Now there is, because these materials are growing. You know, EV metals as a category is growing as fast as oil was in the 1860s. That's the last time an extractive industry like mining has seen this much growth. So the growth means that people will be investing in new technology, but that technology problem has to be solved so that we don't come up with these shortages.
Can I just say one word on innovation? I totally agree with you. And innovation, I mean, that what we're trying to do here in North America, we're trying to set up an all-electric mine. I mean, if you look around the world, there is no open pit all-electric mine. So we're trying to establish that mine. And also in terms of purification, it's being done, as I said, currently in China. They use HF acid, really, really bad. We're coming up with a thermal process. So in terms of innovation, that's what we're doing. We're aiming at being carbon neutral.
And that, just to add another part to that,
you get 10 seconds.
All right.
Over time.
Yeah, well, there is a supply chain and there is these mines, but in what areas of the world there are in, and that's why I just want to add the urban mining, as in recycling, has a huge potential as well as recovering these materials.
There you have it, a really fascinating discussion. I think you'll agree. I just wish I was there to chair it, but quite frankly, if we're completely honest, Chelsea did 100% better job than I ever would have. She is absolutely brilliant at this. Thank you to all our panelists with this talk. It would be utterly spiffing, to use a Texan term, be utterly spiffing if you all could share this podcast with your friends and family. I just think it's a really important topic and really fascinating, and hearing people who work in that industry and who really understand it talking about it is fascinating. So please don't forget to leave us a 5-star rating and a review on your favourite podcast player, as it helps us get discovered and increases our reach to spread the sustainability message. And it actually does. We see really big increases in numbers of people who listen when we get a really good review and a 5-star Dewberry. Marvellous. If you can be bothered, don't feel any pressure, but if you've got a moment, it would be very nice if you feel like it. Yeah, okay. And finally, don't forget to subscribe to our 2 YouTube channels, obviously, which includes Fully Charged Regen, which, it's fascinating. That is where this talk will be hosted on there in video form. Okay, it's a single camera, but you can actually see the people who are talking. And one more thing that I just think it's worth pointing this out, because why we don't talk about it on Fully Charged Show. We should do. I should mention it more. But the fullycharged.show website is amazing. It has just so much information on it, and it's growing all the time. It's where you get Fully Charged live tickets for the next show, which is going to be our flagship UK show, is now being organised. That's on May the 1st, 2nd and 3rd this year. It's going to be massive. It's just amazing how many people are coming. And when I say how many people, I don't mean individual guests or visitors that are coming along to see everything. I'm talking about the car manufacturers, all the companies that do renewables and batteries and solar and water heaters and heat batteries and air source heat pumps and ground source heat, all those things. It's going to be a really, really big exhibition if you're interested in all that aspects of renewables, plus loads of brilliant talks with truly amazing international grade 1 speakers. But the website also includes our A to Z guide, which is now getting really, really comprehensive. So if you're looking for wonderful suppliers and firms that pass the strict, fully charged guidelines for sustainability and clean technology, you can check them out on our fabulous A to Z guide of everything, which is amazing. Because it was initially it was A to Z. It was a little bit patchy. There was a few letters missing. It's really filling up. It's amazing. There's also our merchandise thing, which is, people love that. It's great. We have a brand new selection of sustainable merchandise on there. So and all the sales, all the profits go straight back into making the show better. I think that's very important. We're investing in production, in making us able to make more shows and make better shows. And last, of course, without this, we would not be here. I would not be speaking to you. Patreon. So thank you to all our Patreon supporters, because quite often on the YouTube show, on Fully Charged Show, I just talk about the wonderful Patreon supporters who supply $10 a month or more, which is incredibly generous. But it's important to remember there are literally many thousands of Patreon supporters who maybe it's only $1 or $2 or $5 a month. That is fantastic. It's still incredibly generous. I still am amazed that this goes on, and this is literally what's keeping this show on the screens and coming into your ears every week. So. All that cash goes straight into the production, into making sure we can run the office, run the editing, pay the camera operators. Not me. Don't worry about me. I tell you, nobody pays me. I just get pushed into the corner and ignored. It's terrible. But what we're going to do is make the show bigger, better and more varied. So if you would like to support us, Patreon might be a good fit for you. But as always, there's no pressure. But you can have a look at the Patreon link, which will be in the show notes. And that's enough. That's enough for me. I should just shut up and just go and have a lie down in a little dark corner. But thank you so much for coming along to Fully Charged Show podcast. And as always, if you have been, thank you for listening.